Hello and welcome to Chapter 3, Conditional Execution. In conditional execution, we meet the if statement. The if statement is where Python can go one way or another way, and it's the beginning of sort of our way of making Python make decisions for us. Sequential code, we just do some things. Sometimes that's useful, but now we can have our code check something and then make a decision based on that thing. So the conditional steps in Python are pretty straightforward. The keyword that we're going to use is the if statement. And so if is a reserved word. And the if statement has as part of it a question that it asks. And this is asking if x is less than 10. And the colon is the end of the if statement. And then we begin an indented block of text. And the way this works in this particular thing is this line is the conditional line. If the question is true, the line executes. And if the question is false, the line is skipped. And you can think of it the way this is, right? X is 5, ask a question, is it 10 or not? These questions do not harm the value of x. If it is, then we run this code, and then we sort of rejoin here, and then we test this next if, and if that's true, we do this code, and then we do there. But in this case, it's going to be false because x is not less than 20, and so it just continues down here. So if we look at how this works, it runs this line, then it sees this question, it skips that line. So this line does not run, and so smaller prints out and fini prints out. Okay, and so that's the basic idea of an if statement. And the indentation, when we are done with an if statement, we de-indent back, and there's this little block. This is one sort of if statement, and this is another if statement. And these are the two conditional lines that either run or they don't run, depending on the question, the answer to that question. So we have a number of different comparison operators that we can use to ask these true-false questions that say, is this true? So again, we're kind of limited to the keys that were on computer keyboards in 1940s and 1950s, less than or equal to. So we didn't have fancy math characters, so we just concatenated less than and equal to be less than or equal to. This double equals is the asking, is this equal to? And so that's a little tricky. The equal sign is that assignment operator. If I was building a language today from scratch, I would probably make assignment be arrow and the equals question to have an equals. Or I might say, somewhere I would say question equals. But I'm not building this language, so it's not up to me. So this is the question. Double equals is asking the question is equal to. Greater than or equal, greater than, and not equal. So this is the exclamation point is sort of like not equal. So that's sort of not equal. So that's how we do not equal. So if we take a look at some of these in some examples, all of these are going to be true because of the way x is set. If x is equal to 5, that's the question version. That's true or false. It'll execute that. If x is greater than 4, it's going to execute that. If x is greater than or equal to 5, it's going to execute that. Here's kind of a shorthand where if there's only one line in this block, you can kind of pull it up right on the same line after the equals. If x is less than 6, which it is, true, execute that. Then if x is less than or equal to 5, do that. And if x is not equal to 6, do that. Now, like I said, all these questions have been carefully constructed so that they're true, just to kind of show you the syntax of those comparison operators. Now, you don't just have to have a single line of text in the indented block, and this will be something you're going to get used to. So if we indent more than one line, then the conditional code is actually these 3 lines. So the idea is you have an if statement, you come in, you do an indent, and as long as you stay indented, you stay in that if block. If it's false, it just skips all of those. So the way this is going to execute, x is 5, we print before 5, is x equal 5? That's the question mark, and that's true. So it's going to run all these, and then come back, and then continue on in the de-indent. So all this stuff is running, right? And then it says x equals 6. Well, that was false, so that skips all of them. So none of these lines of code run. So these actually don't run, and it says afterwards 6. So that's a mistake. Those don't run right there, okay, because x is not equal 6. Okay, so indentation is an essential part of Python. We use indentation in lots of programming languages, often to kind of demark demarcate blocks to show where blocks start and stop. But in Python, it's syntactically correct. You can make an error if your indentation is wrong. After an if, you must indent. And you maintain the indent as long as you want to be in that same if block. And then when you're done with the if block, you reduce the indent. In this rule of indenting, comment lines and blank lines are completely ignored. So we're going to tend to like put 4 spaces. 4 spaces ends up being the normal thing that we do, and you'll see all the code that I write has 4 spaces for each indent. If I go in twice, I use 8 spaces. And we have this instinct of wanting to hit the tab key to move in 4 spaces. Now the problem is that it might look the same on your screen. A tab and 4 spaces might line up the same place depending on how tabs are set. But Python can get confused by that. So we tend to avoid using actual tabs in files. And so most programming text editors, like if you're using Notepad or Text Wrangler, there's a place to set the tabs to say, don't put tabs in this document, but every time you hit a tab, move over 4 spaces. And so you hit a tab, but it's like space, 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 space. Now the nice thing about Atom, and this is the text editor we tend to recommend in this class, because it works on Windows, Linux, and Mac, but also because it automatically sets this up. As soon as you save your file with a .py extension, you can sort of hit the tab key with impunity, and everything works perfectly. But the key thing here is that Python insists that you get this right, and if you don't get this right, you're going to get indentation errors, and they're just another syntax error. So if you're using something like Text Wrangler or Notepad, hunt around in the preferences and you'll find something about expanding tabs, or maybe how many spaces each tab stop is supposed to be. And so you check these, and what this really is doing is telling your text editor never put an actual tab in the document, but somehow simulate tab stops using spaces. And so here is a bit of code. It's got a nested block, but it gives you this sense that you have to be very explicit when you're reading Python code of whether the indent is the same between 2 lines, the same, increased or decreased. And so every time you increase it, you mean something, and every time you decrease it, you mean something, and literally if it stays the same, you mean something as well. And so if we take a look at this, here we have a line, and the next line has the same indent. This is an if with a colon at the end, so we have to increase the indent, and now we're maintaining it, okay? So these 2 lines are part of that if, but now we have de-indented. So whether you choose to de-indent this word or whatever, where you do this de-indent affects the scope of how far this if statement lasts, right? It lasts up to, but not including, the line that's de-indented to the same level as the if. Okay, so this is a de-indent. Now we have a blank line, which doesn't matter, and we maintain it. Now we have a for, which we'll learn about in the next chapter, which is a looping structure. Let's do a for runs this 5 times. It has a colon, and it also expects an indented block. Now we have what's called a nested block, where we have an if and a colon, and we go in some more. So this is like 2 indents, right? So these are 1 indent, and these are 2 indents. And so this is a block within a block. And then we de-indent, so that means this print is not part of the if statement, but is still part of the for statement. And then we de-indent again, and then that means this print is sort of on the same level as that for statement. So if you start thinking about this, you want to be able to start thinking that these blocks are the start of the block with the colon line up to but not including this line that's been de-indented. So the for goes this far, right? The for goes up to but not including the line that's de-indented. The if goes up to but not including the line that's de-indented. So as you do this, you'll sort of mentally start drawing these blocks, and pretty soon you will start constructing them as blocks. And it takes a while, but doesn't take forever. But in Python, unlike other languages, you have this is very important, and it matters, and you can have syntax errors if you get it wrong, because you're really communicating the shape and structure of your code using these indents and de-indents. We already saw a nested indent. This is a nested if, so you can put an if within an if, and you can go as far deep as you want to go, like Russian dolls. And so Here we have x equals 42. If it's 1, we indent 1, and then with this next thing we do, these are at the same level of indent, but now we see an if, and it has to indent further. So this is like 2 in, 8 spaces, and then we de-indent back. Actually, we de-indent back 2. And so if you watch this and you take a look at how this works, it runs to here. Oops. Back up. Comes in here. The answer is yes, x is greater than 1. Prints this. Is x less than 100? Well, it's 42, so the answer is yes. So it runs this, and then it kind of continues back to there. And you can also think of drawing boxes around this. This is one if box, and then within that if box there is another if box. And again, it's the indent block up to but not including where the de-indent happens. And this here is like 2 backwards de-indents. So it ends 2 blocks. So 2 blocks are ended by where we place this. We could move this in, or we could move this out. We could have it all the way into here, we could have it to here, or here. And where we put that line depends on how the ends of these blocks are going to work out. So one form of that's a 1 branch if that we just saw, but then you can also have what's called a 2 branch if. And the basic idea of a 2 branch if is that you're going to come in, you're going to ask a question, and you're going to go one direction if it's yes, and another direction if it's no. We call this an if then else. It's kind of like a fork in the road. And the way to think about it is, depending on the output of this question, we're going to pick 1 or 2 of these, but if we pick one, the other one's never going to happen. So it's like an either or. We're either going to go one way or we're going to go the other way, but there is no path where we somehow go boot through both of them. That doesn't happen. And the syntax that we use for this is what we call the if then else. And so the first part is normal if with an indent, and then we de-indent, and then this is another reserved word, else, with a colon, and then we re-indent. And so this is really end up being part of a whole block here, and the else is the part, this is the part that runs if it's false, and this is the part that runs if it's true. The first branch of the if, the first indented block is what runs if it's true, and the second indented block is the one that runs if it's false. And so here we go. It's just if x is greater than 2, in this case it's yes, we're going to print bigger, and then we're going to be all done. And so we do 1, and so this one did run, and this one did not run. So basically with an if then else, one of the 2 branches is going to run, but there's no case in which both branches run. And again, you sort of draw these blocks around these things mentally, and in this one you sort of take from the if, not the else is really part of the block, up to but not including that print, which is back indented, de-indented back to the same level as the if statement. Okay? This Python is actually one of the more elegant languages, even though after a while this indenting, and when you get too far in, it gets a little bit complex. But this is a good way to visualize this with these indents. Coming up next, we're going to talk about some more complex conditional structures. So welcome back. Let's talk a little bit more about some more complex conditional statements that sort of build on this concept of if and if then else. The first thing we're going to look at is the multi-way branch. And so the idea is it's kind of like the if then else, where you're going to pick 1 of 2, but now we can pick 1 of 3 or 1 of 4 or 1 of 5. And it introduces a new concept called the LF. The LF is another reserved word inside Python. And the way it works is it's probably best to look at this here, where it checks the first one, and if it's a true, then it runs that, and then it's done. It doesn't check them all. It's not like it sees that there are 2 logical conditions. It actually checks them, the first one, and how you order these matters, as we'll see in a bit. And so if the first one is true, it runs. If the first one is false and the second one is true, it runs this one and it's done. And if neither of them are true, it falls through, and there's an else clause that is otherwise, and it runs that. So basically, it's either going to run 1 and then skip the other 2, or it is going to skip 1, skip 2, and then run this one. But it only runs in this case 1 of them. But the important thing is it checks these questions in order, and it doesn't check the second question until it finds that the first. It doesn't check the second question until it knows the first question is false. So if the first question is true, you're done. You're done, and you're done with this. You're done with the whole block at that point. So only one of these 3 is going to execute in that block. So here's sort of some examples of this. If we, for example, have x equals 0, it's going to come down here, x is less than true, that's true, so it runs this code, and then it skips down to that. And so it's like this, runs that code, and then skips to the end. Okay. On the other hand, if it's 5, then this is false, and it skips that, and it checks this is true, it runs this code, and then it's done, skips to the end. It goes like false, true, run, end. And then if x is like 20, for example, it runs, false, false, run the else clause, and you're done. So skip, oh, else, run that code, and you're done. So in this case, we ran that, and we didn't run that, and we didn't run that. Again, one of them's going to run. They're checked in order. These questions are checked in order, not out of order. It doesn't look ahead. It just checks in the order that you wrote it. You're the one that wrote that order. And so there's a couple of variations on this multi-way. You can have no else. You can have no else, as in this case. And this just means that it might not run any of them. In this case, x is 5, so it's not less than 2, but then it runs this one. But if x was like 50, for example, if x was 50, then this would be false, then it would skip, and this would still be false, and it would skip, and neither of these two would run. So if you don't have an else, you're not guaranteed that one of them is going to run, because else is like the catch-all. If the other ones are all false, then the else is the one that runs. Similarly, you can have many elifs, but this is where it's really important for you to make sure you know what order they're being taken in. So I've got, this, if this is true, it runs, it goes all the way to the bottom. If, this was, if it's false, 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 true, it runs this one and it's done. If, on the other hand, it looks at it as false, oops, go back. If it runs false, 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 they're all false, then it runs the else, right? This one has an else, this one didn't have an else. They don't have to have them. The key is you can have more than one of these elifs, okay? So I got a couple little things. I'll let you pause right now and look at, the question is, are there, looking at the 3 lines or 4 lines of code, x equals something. Are there lines of code that will never execute regardless of the value for x? And I'll let you pause and think about it, and then I'll explain it to you. Okay, hopefully you paused and thought about it as long as you like, so let me now explain it to you. So we come in here, and if x is less than or equal to 2, it's going to run this first thing, and if x is greater than or equal to 2, it's going to run this, and if neither of those are true, then it's going to run this. Well, the weird thing is, all numbers are either less than 2 or greater than or equal to 2. I carefully constructed this to the point where it would never run this line of code. It is either going to run this one or run that one, but it's not going to ever run this one. So that was kind of like a weird dysfunctional one that I constructed. This other one is a little different. If x is less than 2, we do this. If x is less than 20, we do that. If x is less than 10, we do that. And if none of those are true, we do that. Well, the problem here is between these two lines. The problem is if something's less than 10, like 6 for example, it's also less than 20. So even though there might be values for which this is true, those also are going to have this true. So for something like 6, it's going to run here, and it's not even going to look at this. That's the point. It doesn't even look at this. And so I could have made this more sensible if I'd have moved this little block of code up to there. So this is where the order in which you choose your questions, the way you put these elifs together matters, because it doesn't look at all of them. It only looks as long as it can. As long as it sees falses, then it keeps on going to the next one. But as soon as it doesn't see a false, it doesn't continue. So the last conditional structure we'll talk about is the try and except structure. And if you know any other languages like C++ or Java or JavaScript, you're like, whoa, that's kind of an advanced concept. But it turns out in Python, because of Python's propensity to throw tracebacks in situations where you kind of would like to recover, it turns out you kind of have to use it a little more and a little earlier in your programming skill. So the problem is what if there is a line of code and you absolutely know it's going to make a traceback, it's going to blow up, but you don't want to blow up. I mean, I don't want to have code blow up. If you're using my autograder and you see a traceback in my autograder, that's kind of like, I consider that a failure. I could put an error like, hey, you entered blank data or you didn't enter a number, but a traceback, that just seems like I'm too lazy as a programmer. So we as programmers are supposed to anticipate parts of our code that are going to blow up potentially based on perhaps the user's input and then do something about it. And that's what the try and except are for. It's you take this little dangerous piece of code that might break and might blow up, and you surround it with a try and says this might blow up, and if it fails, run this code down here. Okay, so that's the try, and if you get an exception, the except is kind of like if you get an exception. And the problem is if you are running code, here's a little bit of code, we put hello Bob in and we convert it to an integer, and we know from past experience that this blows up. Right? You can't take hello Bob and convert it to an integer. It's just going to blow up. The problem is, and you know, here we are. It says, oh, you blew up on line 2. That's great. And I'm not very happy with hello Bob and whatever. But the important thing is your program stops. These other lines, they don't, oops, these other lines, they don't exist. Right? It doesn't go any further. Remember the traceback is Python is really confused and I don't know what to do next. So Python is just going to be conservative and stop. So Python stops and your program stops. No matter how much error checking you put down here, it doesn't matter because it's gone. It's all gone. And like I said, we take this kind of personally because the code that you write is like you being put into the computer, giving it instructions. And if the code blows up, well, that sort of wipes you out. You're not in the game anymore. You're not able to do anything. So we want to be able to, especially in these situations where we can anticipate that an error that might happen in the normal course of your program's execution might be something that you want to compensate for. And that's what the try and except does. So here's a bit of code for the try and except. And we just have 2 little bits of straight line code. And so we put a string in here that's hello Bob, and then we're going to convert it to an integer. This is the dangerous code. This code in this case with hello Bob is going to do a traceback. And so we say try, and then we indent the dangerous code, and then we add this little except bit. If it works, the except is ignored. If this blows up, it runs the except. So in this code, it's going to come in, it's going to try this. This is going to blow up, but instead of giving a traceback, it's going to say, "Oh, I've got an available except. I'm going to run this except code, and then I'm going to continue on." And so that prints out first -1. So because we set this variable Eister to -1, like a little flag telling us that something went wrong. And then we keep on going, and now we have put in 1, 2, 3, the digits 123, the digits 1, 2, 3, and now it's going to work, but we still have it in a try block, and then this one works, it does not blow up, and then it ignores the except block. So the except block is only triggered when something goes wrong in the code. It is ignored if something doesn't go wrong. So it's like you bought an insurance policy on this line of code, and when things go wrong, your except block springs into action and does whatever it is that you want it to do in the case of an error. Okay, so that's a pretty useful thing. You got to be a little bit careful that you don't overuse it, because if you put more than one line inside the try part and one of the lines blows up, it doesn't come back to the try block. And so in this one here, we have kind of a simple, silly one where we set the string. We're worried about some stuff. Well, the print statement's never going to blow up, so it's a bad idea to put it in try except anyways. Then we do this conversion, and that's the dangerous part. And in this one, it's going to blow up. And so then it's going to go to the except block and then run the except block and then continue. What it doesn't do is somehow go back and finish this. So these lines are gone. So if you look at it like this works. The try starts. Hello. This blows up. It goes to the except. It runs the except, and it continues on. Never runs that code. So it's not like you took out an insurance on the whole block. Any of those lines can blow up in the block, but whichever line blows up, that is the last line that's executing in that block. Okay? So you tend to want, in this particular example, you would probably, the print statement would go out there, and this print statement would come down here, and you would only put in your try block the single line of code that you think might blow up, because you kind of know print statements aren't going to blow up. So this is an example that's a more common real-world example where the user is going to type some data. And it's users that get us in trouble. So our program starts by asking the user to enter a number, And we know that this could be dangerous. So we're going to do it. We're going to put the conversion from string to integer in a try block, and we're going to set -1 if that's a failure. And then if it's greater than 0, we'll say nice work, and if it's less than 0, well, not a number. So first time we run this program, out comes enter a number. We type in 42, which is a string. That 42 goes back into roster, runs in here. This runs, it's fine. That becomes a 42 number, so we skip the except block, and ival is greater than 0. We print out nice work, and we skip the else. Okay, so it says nice work. On the other hand, if we run it again, this time, the input says enter a number, and we're silly. We enter the word 42, but in words, 40, F-O-U-R-T-Y. So that's a string, and that goes into roster. And then the execution continues. We run in here, and now this is going to blow up. That's going to blow up. Normally, we would see a traceback right there. There'd be a traceback, but we're not going to because we put this calculation in a try and except block. It's going to immediately run the except block, set ival to -1, continue on with the program. See, you are not blown up at this point. And if ival is greater than 0, well, it's -1, so we're going to hit the else clause and print out not a number. So we've done error detection. The user set something that caused a line of our code to kind of blow up, but we put that line in a try and except block, and so we caught it, and so we dealt with that fact. So in summary, in this, we talked about if statements, we talked about else, we talked about try and except, how important indentation is to mark blocks where they begin in the end, and an else if and try except. So up next, we're going to talk about loops and iteration.